Welcome. I'm your host, Mark Gorenberg. I'm delighted to welcome you to Zetta Bytes Live. Zetta Venture Partners started in 2013. We're the first venture fund focused purely on AI, B2B business models, seed stage. To date, we've made 40 investments in enabling AI platforms and applied AI. We've had 6 exits to date. One IPO, Domo, where we were the very first investor, market cap now 1.6 billion, and 5 acquisitions, 2 of them by Google. One Bebop that became Google Cloud, and also Kaggle, and the largest data science community now with about 4 million data scientists. And Anthony Goldblum was our last Zetta Bytes Live speaker, hosted by my partner, Ash Fontana. So Zetta Bytes Live does deep dives into state-of-the-art in AI platforms and enterprise applications with top industry leaders in AI. We believe technology powered by data will reshape business as we know it. And we've set up a program to tell stories about that. And we'll feature deep dives into the state of the art in AI platforms and showcase some successful applications of AI. As we're doing with our guest today. Our guest today is Professor Karim Lakhani from Harvard Business School. Professor Lakhani specializes in technology management, innovation, digital transformation, and AI. He's the founder and co-director of the Laboratory for Innovation Science at Harvard, known as LISH. He's co-founder of the Harvard Business School Digital Initiative and co-founder and co-chair of Harvard Business Analytics Program. And he's also taught extensively in Harvard Business School's MBA, doctoral, and online programs. And he co-chairs the HBS executive program on competing with big data and business analytics, which might be particularly interesting to many of you out there. He's published over 150 peer-reviewed papers now in leading journals. He's co-author of 2 books on open and distributed innovation models and on perspectives in free and open source software. And he's also co-author now of Competing in the Age of AI, which just came out this past year, a book published by Harvard Business Review Press. His research has been featured, well, frankly, almost everywhere. Business Week, Boston Globe, The Economist, Fast Company, Market Watch, New York Times, NPR, Wall Street Journal, Washington Post, Wired, and many, many radio stations, and I'm sure TV by now as well. And of course, I'm particularly delighted because Karim got his PhD at MIT. And he's also on the board, by the way, of a number of private companies. And in full disclosure, we're on a board together at an MIT Harvard spinout called Vidya Health, which uses AI to improve dentistry. So we invite you to submit questions using the Q&A button on Zoom, which we'll get to in the latter part of this hour. And last but not least, I want to let you know, to those of you who are here today, we'll be emailing you a survey. And those of you who complete the survey, we'll be sending you a complimentary copy of his book, Competing in the Age of AI, second time. As a thank you for being here with us today. So Karim, welcome to Zetta Bytes Live, and thank you for being here today.
Hey, Mark, thanks so much for having me here. It's a pleasure and looking forward to our virtual fireside conversation.
Our virtual fireside conversation, that's the way of the world today.
Yeah, exactly.
So by the way, so whenever we talk whenever we talk with new companies, my partner Jocelyn always wants to hear the origin story.
Yeah.
So in her tradition, if you don't mind, can we start with your journey? How did you grow up, and when did you know you wanted to be a professor, educator, leader in data and analytics and management?
Yeah, it's all a big accident. I always scratch myself to say, like, am I really here at this office at Harvard and so forth? Yeah, I didn't have any intention whatsoever to be an academic. In fact, I was, prior to me deciding to do a PhD, I told my advisor, like, I don't want to be writing obscure papers in obscure journals. And that's what I do these days. I mean, that's the bread and butter of academia. So, I actually was born in Pakistan, and then when I was 12, our family moved to Canada. And so did my high school there, went to McMaster University in a program called Electrical Engineering and Management, because I always wanted to be at the interface of technology and business, which is I had. And then this is all last century, and then I joined General Electric in one of their their programs. And so I joined the technical leadership program, which at that time in Canada, I was actually basically assigned to the medical systems business, the healthcare business, and put me through a whole bunch of rotations in the US and Canada around new product development, marketing, sales, and so on and so forth. And so it was a fantastic lesson. Spent 4 years there. And that's where I started to see that the world was changing. My first encounter with Mosaic, the browser, was at a radiology conference in Vancouver. I was in Vancouver, and this radiologist radiologists tend to be the most geekiest of all the doctors, have all the fancy toys. And so he showed me Mosaic. I'm like, what? Like, I'm used to Gopher and text, and this is a totally different view of the internet. And I just clearly remember seeing that, going, wow, the world is changing. And then through my experience at GE, again, hanging out with radiologists, I got to see the start of open source. And it never made any sense, because GE, if you remember, GE's tagline used to be like, we bring good things to life, GE does. And all of a sudden, these random people in the world were bringing good things to life. It didn't make any sense. And I probably forgot about it, but somehow in the back of my mind it was there. And then I went to MIT for a master's degree in technology and policy first. And by sheer accident, I took a class at the Sloan School with Eric von Hippel, and he said, you write a paper, and he was talking a lot about user-driven innovation, how users innovate. And I wrote a paper saying, oh yeah, it's not just singleton users, it's actually communities, and look at this open source example. So at the time, this was like my first year there, and I was working that summer at BCG. Some TA, graded the paper, gave me an A in the course, and then I think Eric then reads only the papers that get A's, lazy professors. And so he calls me up. He goes, hey, I read your paper. You go, I already got an A from you. Why are you calling me now? He goes, I want you to come work with me. I'm like, no, Eric, you can't afford me right now. I'm at BCG. So he was persistent, and this is the theme with Eric. He was persistent, and then that fall he invited me over to his house. Super nice guy, and he said, you got to do your thesis with me, your master's thesis with me. I'm like, I'm doing computational biology stuff. He goes, no, this is a really important topic. So he finally convinced my wife, to say I should switch over. So I switched with him, and that was like the first time I got the research book. I got this taste of, I could go deep into something and really understand it, and do sort of first order research, like describe the phenomenon, understand some causality, explain it, make sense of it. And Eric was my mentor to sort of help me do that. And so I did this study way back then for my master's thesis about the most boring part of open source, which was support. And support at that time on Usenet. Remember, there's a thing called Usenet, and Apache was being supported in Usenet. And our thesis was, if the most boring parts of open source are being taken care of, then for surely the software itself is actually pretty robust. So I did that, and so that was fun. And then I went to work at BCG, and then Eric was again very persistent. He would call me every 3 months. How's it going? We got a paper to write on your thesis. So we wrote the paper while I was working at BCG, and I finally got sick of consulting. And he said, "Okay, you should come back to school." So then I came back and did my PhD with him. And there is where it got interesting, because I dove into open source, but I started to open my eyes about everything else that was happening around open innovation, and did a whole dissertation on both open communities, but also open contests. And that led to a job at HBS. And I started, so it was an easy transfer, just one subway stop away from where I was living. And then started to come here, started to teach here, do research. And that's where things got interesting, because HBS, is like, okay, you got to keep publishing in the top academic journals, but you also got to talk to managers. You got to be relevant to practice. And so we write cases, and we, write HBRs and so forth, and did some exec ed. And in one of my exec ed sessions, I was talking about all these sort of distributed models for innovation. And this guy, Jeff Davis, sort of comes to me and goes, "Oh, I'm from NASA. I'd love to hear you more." Blah blah. Gave me his card, and I was a busy assistant professor. I said, "Director at NASA." Okay, whatever. I put the card away. Again, persistent. Jeff kept calling me. He goes, "I want you to come to Houston. I'll give you a tour of JSC, but we really need to hear about what you guys are doing there." So then I looked at him closely. He goes, he's the director of the directorate. He runs the directorate of the Space Life Sciences. I'm like, okay. So he's he's a physician, chief medical officer for NASA, and has a 1,000-person team that keeps astronauts alive in space. I'm like, okay, if this guy cares about my work, I better go talk to him. So that started this relationship where we started to do open innovation projects
Okay.
for NASA. And that's where things got so interesting, because it was Jeff, it was Jason Kruzan, another partner at NASA, and actually Tom Khalil, who was in the Office for Science Technology Policy in the White House. And so we started to run these experiments with NASA, and we were getting these very high-performing solutions going to Top Coder. This was the precursor to Kaggle. And while I'm running experiments to understand, the mechanics of incentives and information and teaming, we're creating all this great code. And all of these were early machine learning prototypes that we kept seeing. And they were blowing past all the solutions that were out there by NASA. So that's got me exposed to sort of the start of AI, the early days of machine learning stuff and code coming through. And so I did a deep dive into that on the research side, but then also started writing cases about companies that are powered by AI. And so those two things came together, like both the research on how the AI got developed through these contests and communities, but at the same time, understanding how that was changing the role of companies as well.
Oh, that's pretty amazing. So Eric Van Hippel, for those in the audience, is a guy at MIT who, he had the original ideas on, I would say, bottom-up models, user models. So it's interesting that he had the theory and you were put it into practice.
Yeah. It was a great, I just remember this. And the thing is that Eric's stuff, I also saw at GE, because a lot of our functioning novel stuff was actually being developed by doctors. We were good at making the magnet, perfecting the algorithm, but like the novel utility was actually being invented by physicians in the field. And that was Eric's theory, that basically users develop functioning novel innovations, manufacturers do dimension of merit innovations. And so I saw that, I go, oh yeah, but this is happening at scale. It was not just, he had like a farming example, some radio example, this and that, industrial side. I said, no, in software, this is becoming the standard. But, this is 97, 98. So, I would tell my Silicon Valley friends this open source stuff, and they'd be like laughing at me. They go, no, that's not how you develop software. You need to be in an office co-located and sitting there and doing that. And so I'm glad it worked out.
I think you were probably way ahead of your time. But you took these partnerships. And it's interesting, this evolution to work with real industry, because you took these partnerships like NASA, Harvard Medical School, Broad,
yes,
Top Coder, Linux Foundation, and 10 years ago you started the laboratory.
The
laboratory for innovation and science at Harvard. So tell us about the lab then over the last 10 years, the digital innovation you put in place, and when you got the aha moment about AI being a big deal.
Yeah, so I think the idea for the lab, came from NASA. They said, look, I wanted to, most social science, economics, sociology, psychology, most of us sort of, especially economics, sociology, management, most of us sort of get archival data. We get archival data, we look at the archival data, and then we try to draw some causal inference, torture it with econometrics to get it there. Of course, the gold standard in any research is a randomized controlled trial. We're hearing all about RCTs right now with the vaccines that are coming through. But they haven't been deployed as much in the social sciences as they are the norm in the natural sciences or in life sciences. The one exception has been the field of development economics. Development economics has really shown, and again, this is an MIT story, MIT Harvard story, have shown how to do really careful studies that have massive impact on the well-being of people in poverty and so forth. And so that became like the thing, could we do innovation experiments with companies? Could we actually get the same type of causality that the dev econ people were getting that for innovation had not been done before? So myself and my colleague, Kevin Boudreau, a good friend, co-author, we both had gone to MIT for our PhDs. And so we said, okay, let's see if we can run an experiment at NASA on Top Coder. And we ran the experiment. It worked great. We got machine learning code. We didn't care about the code. We're like, okay, like we got all this nerdy data about, how people select, how much effort they do and so forth. And then NASA comes to me and says, okay, let's do more. I'm like, I've got enough data here to keep you busy for 3 papers. They go, no, you don't understand. We want to scale this across NASA. So I said, fine, if you need to do that, then you need to support me in a very different way. And so that's where we established the NASA Tournament Lab to say, okay, we're going to teach NASA how to do this, but also we're going to do it with NASA, take their problems and put them on various platforms. But we're going to learn how to think about the social science behind contests and how people work and so forth. So that got us going. And then very quickly, our colleagues at the medical school said, oh, if you can do this at NASA, why don't you do it with us as well? So we started to do that. And again, we saw the same kind of things. And that's where my paper streams got weird. Like all of a sudden, I'm publishing in Nature Biotechnology. I've published in JAMA Oncology, and so on, like highly technical journals, as I'm also publishing in Management Science and Rand Journal of Economics and Organization Science and Research Policy. So it's sort of this thing about like, oh, I can do super technical work with our team, but also we can then write about that as well. And that's where it was through these contests on Top Coder that all this AI stuff started to emerge. And it was just like, wow, like we were cheaper, faster, better consistently against elite institutions, right? The best people at the med school, the best people at the Broad, the best people at NASA, some kid in Estonia, right? Some kid in Paris, some policeman in Brazil is outperforming these guys, right? And that's where it became so interesting.
Well, you talked early on. I know one of the things that struck me in the book about your work at Lish on AI included Dana-Farber. So I guess Dana-Farber was one of your early companies to work on this intersection of healthcare and AI.
Yes.
In particular around lung cancer.
Yes.
And you talked eloquently in the book about that. If you want to talk about that.
Yeah. So look, that's like one of the most proudest papers I've written with our team. And so this was with my colleague, Eva Guinan. So Eva is a radiation oncologist at Dana-Farber, professor at Harvard Medical School. And she has now more economics papers than your average economist because we've collaborated so much on projects together. And so as we've done all this machine learning stuff, she said, look, much of the machine learning stuff has been about image recognition, right? Great. But it's been sort of diagnostic story, like, what is this? Is this cancer or not cancer, and so on and so forth. Cadwell has done this at scale. But what about treatment? We need to also apply machine learning to treatment. And so she goes, we have data on, how you create treatment plans for lung cancer. And part of that involves basically fully delineating a 3D tumor, multiple 3D tumors in the CT scans. Wow. And is it possible for us to run some contests to get code for that? And so we did. We spent a good 4 months ahead of time just figuring out the problem, how would we measure, effectiveness and so forth, getting the data, cleaning the data, getting IRB approval. And then we ran it on Top Coder, and then 8 weeks, 60 grand. And all of a sudden our code is better than all commercial software that's out there, but also as good as the average Harvard trained radiation oncologist, right? And the best part is that some of the winners took software from autonomous driving projects and applied it here, this arbitrage. And you go like, what does autonomous driving have anything to do with cancer? You would never see those two fields intersect. But if you think about it, it goes, of course it has everything to do with it, because autonomous driving is all about boundary detection, object shape recognition, right? Weird objects with weird shapes showing up, and you need to know what's the end of that object and where's the road is, right? And so that's exactly the same problem in lung cancer therapy, right? You're gonna just beam with radiation the cancer cells, but not everything else. How do you detect those cancer cells, and then how do you create the right shape to do that? Is exactly the same problem. And that's what gave us a breakthrough. So it was just like a big aha moment. And then the fact that we got to publish in JAMA Oncology was incredible. But also my joke is, the last time I took biology was in 10th grade, and I was awful. And here I am publishing in JAMA Oncology on an AI project saying that, again, the costs for us to innovate with AI have dropped radically, that we can make these breakthroughs.
Well, you train on a little bit of data and you can be as good as the average radiologist, and then you train on more and more data and you're better than any radiologist.
Exactly. I mean, just think 8 weeks, 50 grand, and we got these solutions. It was just unbelievable to me.
That's great. So I wanted to know, how did you and Marco come to write the book?
Yeah.
And in your research, particularly in your research along the way, what surprised you What aha moments did you get in your journey to put this book together?
Yeah, yeah. And so this book comes together because I'm seeing all this AI stuff, 2011, 12, 13, 14, 15. And then Marco and I started this course in HBS called Digital Innovation and Transformation. And what was fun about that course, what's great about, again, being a faculty member at HBS is like we have an intellectual hunting license and we write these cases. And what cases mean is that I go talk to companies. I call them up and say, hey, I want to do an HBS case on you guys. And I get access to these companies and I do tremendous vicarious learning from these guys. And we go spend time with them. They share their secrets with us. We write it up. The cases have to be approved by the companies. They can't be just published as a journalistic piece. We actually work with the companies, get them approved, and then we get to teach them. And so that just basically gives me many more reps in the economy with what companies are doing. So we're looking at this digital transformation story. And our thesis was Marco came from the Microsoft side. He did his early work looking at Microsoft and their platform and their ecosystem, did early work on sort of keystone strategies and ecosystems. And I'm coming from the open source, so the anti-Microsoft view, right? And coming in, and Marco actually hired me into HBS, right? And I'm like, are you sure you want to hire me? Because I'm going to try to destroy everything. Now, of course, Microsoft is like platinum sponsor of the Linux Foundation, so the world has changed in 20 years. But what we saw in our work is that this whole notion of ecosystems and platforms, both from open source, but also from Microsoft, was the dominant way to organize a software business, right? And so forth. You're either a holder of the ecosystem or a participant in the ecosystem. But those dynamics were now basically, because of the internet, happening in every single industry. Every single industry was basically getting these ecosystem dynamics. And there's a healthy notion of platforms and network effects and so on and so forth. And it was no longer just a software story, but in industry after industry, the same thing was happening. So we were writing about this, from Andreessen's software eating the world, what does that mean and how are companies responding? So we see this rise of platforms. And so our first set of courses were around cases were on that, and our course was around that. But then we're in the operations department, so we always want to understand, but how does it work? How does this company work? Is it the same way as GE is set up, right? Or is it something different? And that's when we had these aha moments, because we'd walk in, you look at a Google, you look at a Facebook. I remember talking early days of Google, and this is 2001 or 2.
Right.
And talking to their when they were talking openly about what they were doing, and I was talking to their data center people. I think they said, "Oh yeah, we have 20,000 servers, and we have 5 people managing it." And I was like, or maybe 8. I'm sorry. I'm like, what? That I've seen all these other data centers, and it's like armies of people in demand. How is it that you guys are doing? So these early inklings as to how these platform businesses were actually running themselves. And the big aha was, they're no longer have the old processes, the old operating model.
Right.
What they're doing is that they are sort of saying, let's automate our bottlenecks. Let's actually throw technology at it and then rethink the ways in which machines do the work instead of humans doing the work, right? And so the simple example I use when I talk to exec students is like, there are 100 million or more auctions running every day on Google. There's no auctioneer sitting there saying, what's your bid, what's your ask, that kind of stuff, right? It's fully automated, right? Pricing, even to the point now that even the ads themselves are automated, right? What the content is of the ads, right? That's a system, that's a value capture mechanism that works at scale without human intervention. Humans are the edges of it, but it's the machines that are doing that, right? And then you go, and then you start looking at, you look at Netflix, right? Netflix at scale can't be driven by humans. Yes, humans are on the edges, maybe making some content decisions and so on and so forth, but the operation of Netflix as a service is fully automated. Your Netflix is very different from my Netflix and so on and so forth. And I think that people in the audience understand that and know that. But that was the big aha that, how we think about operating model, which is how you achieve scale, how you serve lots of customers, how you achieve scope, how you offer them many different things, and how you learn, that is being infused by AI. That becomes your value delivery mechanism, but also your business model, how you create value, how you capture value, that's also been fully automated, right? And so our view was that there's a new shape of a company showing up, organized very differently. Which is in many ways colliding colliding with existing companies, and that was the big aha. And in writing this book, we tried to write this book 3 times and we failed. Every time somebody else wrote the book we want to write. And what's good about this book is that it includes all the homage to platforms and network effects. Those are critical, but and I think people know that, but that's not enough. It's really that combined with a change in your operating model, right, that drives automation, but then also has what we call learning effects, right? You can learn about your customer behavior and what's going on from the data from all the interactions, and that makes your value capture and your value creation even sharper. So that thinking, I think, was like the big aha for us to put this together.
You basically become the center of the ecosystem without even trying.
Yes.
You become the one that brings all these pieces together, and the ones that are strongest to do that. You talk about this in the book.
Yeah,
basically,
and exactly right.
Connector.
Yeah, you're the connector, and it's the same thing. Like like what Airbnb is doing is the same as what Marriott is doing in the end. You're renting beds, right? Airbnb's operating model is very different from Marriott's, right? But okay, you go fine. Okay, they're trying to get. Yeah, I get that, Karim. That there's like individual rooms and houses versus hotels. I go, yeah, that's it. But if you just think about the investments they will make in data and in analytics and AI, are orders of magnitude more than what Marriott will ever do, because it's not just Marriott isn't set up that way to do what Airbnb does, right? So it's a different beast of a company doing the same thing as what a traditional company does, and that's the collision that I think is very interesting.
So you coined the phrase AI factory.
Yeah.
The book talks quite a bit about that.
Yeah.
And we all look at this idea of data and algorithms, how we put that together, how we do virtuous loops, et cetera. But I found it really fascinating that you actually coined a phrase for that. And basically the autonomous AI factory is probably another step that you talk about there.
Yeah, can I share a slide with you on that? So I think
please.
kind of fun.
Please.
This is this is like plug for my book, so I apologize. So this is the slide. This is the AI factory, right? So by the way, the concept I'm so grateful to be in the Harvard ecosystem. This notion of the AI factory actually came from my conversations with my friend Vladimir Jasimovich, who runs Continuum Labs here in Silicon Valley. And he came and said, oh, there's a data factory that many of these companies are doing. And I go, yeah, it's not just data factory, it's actually AI factory. So his notion is that you basically have to build a data factory. And we took that and we built upon that and had this view. So let's first contextualize this picture, right? So all firms have analytics at one point or the other, and I think Bob has asked this question to us in the Q&A, right? Most firms have databases, infrastructure, technology in a binary fashion and so forth. So that's exactly right. Most enterprises have analytics, but that analytics is in many ways the craft model, right? Like what handcrafted analytics, right? You've got a database, you've got some infrastructure, you're gonna call your buddy in IT, you say, can you run the SQL query for me, please? They'll say, well, next week I'm tied up. Next week they'll send you like, okay, what was that query again? Send me an email, or you Slack them, okay, fine. Then they'll send you a CSV file, then you'll import it into your RStudio, and then you will sort of do some analysis, and then you'll have a report, and then you'll embed that into a PowerPoint, and you present it to your manager, and there'll be like some retrospective view of the world. At best it might be like, oh, yesterday or so forth. But that's a craft-based way. That's how we used to make machines. That's how we used to make shoes. That's how we used to make our clothing. It was a craft-based way of doing things. But the Industrial Revolution was all about automation, industrialization, thinking about modularity, thinking about interconnecting parts, replaceable parts, and so forth. And the revolution and the economic benefits that the whole world has gained is because we've industrialized these prior craft processes. Now, of course, we have nostalgia for the handmade leather jacket from Tuscany, and we want that, but the majority of humanity needs manufactured stuff, and we need that, right? I mean, the super rich people can afford that. The rest of us, just go to Target and buy our jacket and move on. And the thing is, the same thing is happening with data and analytics, right? Most of us have these craft-based models. this AI factory, which is at the core of, from our sense of, Netflix and Facebook and Google and, what Domino's trying to build a model-based company, right? Says we're going to have a process that ingests a ton of data, and then we invest in our data pipeline, right? Gathering, cleaning, normalization, integration. We have algorithm development, either it's off the shelf or we do some tweaking, infrastructure development, experimentation platform, and we prioritize and deploy. And the AI factory basically does three things, right? And three things. One is that it does predictions, right? The second is that it does pattern recognition. And the third thing is that it does process automation, right? So the three Ps, right? And if you now start thinking about any enterprise, right? There's a ton of predictions going on in enterprise, right? Which students are going to come to HBS? Which will do well? Which students should get promoted? Which should be tell them to take a year off? Those are all prediction tasks, right? Which customers are going to come? What should my pricing be? What should my inventory be? What machine is going to break down? What machine needs repair? All those things are prediction tasks. So you can model your enterprise as predictions. And if you do that, there's a ton of scope for applying AI, right? Same thing about pattern recognition, right? Just think about how much time is spent by managers and executives doing pattern recognition. But it's all intuition-based. It's all sort of like pre-Moneyball scouting reports, right? And then the AI factory can actually, again, drive some rigor and show you patterns that don't exist. And then finally, there's processes, and the AI factory can do process automation. So that's the notion that came to us. And as we dug into examples like Ant Financial, right, Alibaba, so on and so forth, all of these companies have AI factories at their core, and that was like a big aha for us to put together.
Interesting. So the aha, you talk about the aha here. I mean, this is sort of product. They build the factory, they can build a product. And after a while, the technology becomes relatively straightforward. But you also talked in your book about something that I found fascinating, which is, I think you said the line that basically technological change is easy, organizational change is hard, which maybe gets to the heart of why this would be coming out of labs at Harvard Business School instead of just coming out of other types of labs. But it seems like the wrong company implementing this is just not going to get there. There's so many other. Tell us about the organizational challenges and who got over those organizational challenges that you saw.
Yeah. Look, I think this is. I still think technology is easy as a technologist, Right. And it is the organization. It really is. Again, being in this dense ecosystem here at Harvard, at MIT, there's a nice density of sort of economists and sociologists of innovation, and studies going back 70, 80 years as to how companies adopt technologies and so forth. And one of my colleagues, two of my colleagues here at Harvard Business School wrote the seminal paper in 1990, pre-internet anything. This paper is known as architectural innovation. So it's Rebecca Henderson. She was a PhD student at Harvard, then went to MIT, and then was back at Harvard. Amazing colleague. And Kim Clark, who used to be our dean. And the question they were asking is like, why do incumbent firms fail? So Kim Clark had this program of research that said, why do incumbent firms fail? And so there were two streams of thought. There was Rebecca came first and did architectural innovation. And then the person who got super famous by asking the same question with a different answer, complementary answer, was Clay Christensen. So Clay was also Kim's student, and he saw disruptive innovation. So disruptive innovation story, everybody knows, right? You have a technology that's lower price, lower performing. It opens up a new niche. New niche comes in, right? And over time it gets better and better and better, and then it takes over the existing technologies that are out there. And that shook Silicon Valley to its core, right? The famous picture of him and Andy Grove, right? Unfortunate magazine. Unfortunately, both of them have passed away. It's just so sad. Now, Rebecca, prior to Clay, says, I also see successful incumbents not adapting. But her view was that, in fact, it wasn't new technology that was killing them, it was new architectures. And the way to think about that is technology has two things. It has components, all the different widgets that come together, and an architecture, right? So first ever cell phone had both new widgets and a new architecture, right? Because you needed antennas, you need batteries, you need base stations, so new components, and it was put together in a new way. You know, then you can think about incremental. Like if you think about iPhones 2, 3, 4, 5, 6, those are all incremental changes. The components didn't change, the architecture didn't change. If you think about, again, iPhone, right? You know, sort of Touch ID, Face ID apps, all of those are modular. You just take out a component, put a new component in, but do the same functionality. Architectural innovation is when you take existing components, but you organize them in a new way. And her view is Rebecca's view was that it was the failure to recognize new architectures that were killing companies, right? Because they would see the components, they go, we have all the pieces.
Right.
Remember, Nokia said, this phone is a crappy phone. We have touchscreen, we have an app store, we have a music phone, we have a map phone, right? What kind of phone do you want? I've got a model for whatever desire you have.
Right.
But that wasn't the point. It was the re-architecture that mattered. And so architectural innovation is critical. And so Rebecca's view was that architectural innovation is both hard to see, but also what we see in industry is that the architecture of the technology mirrors the architecture of the company. There's a one-to-one almost mirroring of that. Mm-hmm. And it's been talked about quite a bit in the literature. And when the architecture of the technology changes as a new dominant architecture, then the organization also has to change. Right. But this org change we know is tremendously difficult.
Especially for large companies.
Exactly for large companies. So this change is what is so difficult. And so they look at the architecture, but they focus on the components. They say, my component X is better than your component Y, this kind of stuff. But saying the customer value has shifted the architecture. You're just not seeing it, right? And that's exactly, again, what Amazon did to retail, right? Brand new take existing pieces, new architecture. My favorite example these days is Peloton, right? Yeah. You look at Peloton, every single piece of it has existed out there, right? They just put it together in a new package, a new architecture, and also change the business model, right? Yeah. Because now what you could do is you can say, oh, I can build a subscription business. I don't need to pay per use. I can do a subscription business. I can build the best spin experience for you in your home. You don't have to go to yes, some people like going pre-COVID times and sweating together and coughing and breathing on each other. That's all going to change, I'm sure even after vaccination. But what matters was in New York, touchscreen, internet, broadcasting of, there's been live streaming of fitness content forever, but in this new architecture with music was not done this way before. And so I think this new architecture is what, and it's the same classic story, right? They went to SoulCycle. They said, let us stream your classes. And SoulCycle says, no friggin' way. We're all about what happens with the 50 people in the studio. We don't care about 1,000 people in, wherever doing our class.
So if you think about the company du jour, the best example perhaps of re-architecting is Moderna. Moderna today, by the way, right? Moderna got their FDA approval today.
Yes.
You wrote this phenomenal, here, I'll show this. It's all scratched up because I've been dog-earing it and writing on it, but in September, you wrote a case study on Moderna as the true architectural change, a company that is a AI technology platform and not a drug discovery company. Yeah. So they turned this on its head over about 7 to 10 years.
Yes.
But can you talk to us about this case study and this exciting company?
Yeah, so look, part of this case study was like, people saying, okay, Karim, great, AI, blah, blah, blah. But you're just talking about consumer giants. Like, come on, like I can't be Facebook. I can't be Google. I can't be this. I can't be like billion customers. Like I can't, like, this is only for those guys, not for me, right? My problems are too exotic. I'm too specialized. I'm in this, whatever. So I've been on a hunt. And if there's people in the audience that have examples of, real world AI and real world, full of atoms or cells settings, please come to me and let me know, and I'd be happy to figure out if we can do a case on you guys. So Moderna, again, pitching our alma mater, a great Harvard MIT collaboration story as well. It's just fantastic. Nubar Fian, who's on our faculty right now, teaching with me as a co-founder, comes about, producing companies that comes about with their view at Flagship Ventures to say, we don't want to be in the white space, we want to invent new space, right? They go,
right.
And they always ask what if questions. And part of this was a conversation that Nubar got into saying, could you use mRNA to make drugs inside the body instead of it being done exogenously, right? And there was some early work elsewhere that was not so promising, and then they went ahead and figured it out. Now, the thing about them is that in many ways, this is the first information molecule going into your body, right? This is not a molecule that is going to respond to your cells and so forth. This is design. It's a programming instruction. mRNA is programming instruction to go into your cells to produce a specific protein, which then tunes your immune system to then be responsive to the COVID virus. So on its head already, it's an information molecule, right? Very different paradigm. And then what they realized is, oh my goodness, like, we don't know if our first, if we said we're going to do disease X or disease Y or disease Z, that it's going to work out. We just don't know, because there's so much uncertainty in science, right? And so we're going to do a platform. This information molecule has many different applications across the board, right? I'm just going to do 20 programs. So as an early stage biotech to come in and say, we're going to do 20 programs, vaccines, cancer vaccines, and this and that is crazy. But they were able to show really good data that convinced their investors as well as partners to do that. And so this is part of their thing. They're a platform company where the same technology is being applied to a whole bunch of different diseases, and they can succeed with that. But also, what was amazing is that Stefan Bancel, the CEO of the company, had this big moment where he walks into his scientist's office and sees a wall of Excel sheets. And his scientist was very, very proudly sort of coding every single Excel sheet, right? And every single cell with the codons, right? With all the ACTGs to sort of laying out the mRNA sequence. And he's like, if there's one slip up anywhere in this process, that's 6 months to a year's worth of experiments down the drain. That was his big aha moment. He goes, we can't run like the way we used to do pharma, which is like take notes, figure things out, pass the note over to somebody else, go back. This whole process has to be digitized and it has to be automated. So they have invested a ton on basically automating the clinical processes, their research processes, and their manufacturing processes, to the point now where that somebody can design a drug on their web browser, and then the next day the factory makes it and gives it back to them. I mean, that level.
Yeah.
The coronavirus side, the actual time for them to create the molecule was actually 4 hours. The rest was 4 hours.
But normally it takes about 10 years.
Yes, 4 hours to make the molecule. And because they've done this before with other works with the NIH on SARS and MERS before, they knew about the spike protein. They knew the safety profile already. They knew all that information. So this is again, the platform learning. This molecule that we have has all these capabilities, right? And that allowed them to basically 4 hours to build. The rest was to prove out safety, this and that, for the regulators. And then basically, they saw the and they never actually ever touched the virus. They had the sequence of the virus from China showed up to them, and then they used that to then create the thing, and then they made the submission. Wow. So just a remarkable, amazing story of using AI at scale. It's fantastic.
Right. I highly recommend everybody to read the case study. It's quite an amazingly well-written case study. And I think with that, maybe we'll go to our audience questions. So Todd, if you want to queue up, I think we have Max Hoffer, who's going to ask us a question. Max is a PhD and lecturer at EPFL, Karim, in Switzerland. And you're the expert in open source, Karim. So Max is your perfect question.
Hi, Professor Lakhani. Thank you so much for these exciting insights. It's really fun listening to what you're saying.
Thanks.
I've got two related questions. The first one being, when you're accumulating and developing these assets, especially these intangible assets that you've mentioned, what should firms pay particular attention to? And the second one, in a world of open source technologies, how can firms build and sustain competitive advantage?
Great questions. So first is data, right? I think I can't tell you enough. And I think most sort of digitally native or AI native firms get data and the value of data and building infrastructure, but incumbents are just terrible, right? And so I tell executives, like, invest in the janitors, invest in your data pipelines, invest in cleaning your data, do that first, because we know garbage in, garbage out, and talking to folks at these big tech firms, when they try to work with their partners in other organizations, they always run into the data silos, the data cleanliness, all that kind of stuff. So if you're going to be playing in this game of AI factories, which I think everybody has to, right? AI factories, my view, is going to be a necessity, either for your own operations or if you're going to be sitting talking to Amazon, talking to Google and so forth. So investment in data and infrastructure. And then, by that way, that also means organizational change, because right now data are siloed and hidden and not shared across organizations. And so you've got to work your ass off on that. And so I would say, don't hire the MIT PhD yet, right? Go, or the ETH or EPFL PhD, right? Fix your data thing and then hire them, because that's the only way. And if you hire those guys, they're going to be spending cleaning data. So you all of a sudden taking a high-end PhD guy and then making them do sort of data engineering work, which is a total waste of time for their skill level. So I think data first thing. The second thing, which is very interesting, I'm on the board of Mozilla, open source company for a browser. And this is one of the reasons why I joined Mozilla's board, because in many ways, the open source software wars have been won, right? Microsoft now is premier funder of the Linux Foundation, right? When before they were saying it was an IP destroyer, right? All of a sudden they're members of that. So there's been a whole sea change of that. My view is that, in fact, Google, Facebook, Amazon, everybody does open source, right? It's not as if they don't do open source. Yes, we have fights about how open source are they really, but the sort of the belief of sharing the code and so forth is out there. I think the game has shifted to, in fact, how you build complementary assets around the algorithms. So algorithms themselves aren't going to, before we'd be secretive about our algorithms, but now if TensorFlow is available for free, right, and Google's business model is for them to have the best hosting service for TensorFlow, they're going to keep making all that stuff for free because they just want usage and consumption of their services. So then us, who are playing in the AI space, we have to think about our business model. We have to think about value creation, value capture, and how we sort of do this in a way that allows us to have complementary assets, build network effects, build learning effects.
Mm-hmm. That's super interesting.
Yeah.
Thank you so much. Appreciate it.
Thanks, Max.
Max, thank you. Todd, I think Anusha is next. Is that right? Yeah. Well, anyway. Anusha, hi, how are you? Welcome to Zetta Bytes Live.
Thank you. Thank you for the opportunity, and thank you for having this conversation today. My question was on legislation. How do you think legislation in the US is going to evolve as customer data is being used more and more? And also maybe if you have a perspective on the customer sentiment itself, I would love to hear that.
Yeah, look, I think this is such a great question, Nusha. I'm so glad you asked this. I think we spend a whole chapter talking about the ethics of digital scale, scope, and learning in our book, and that was the toughest chapter for us to write, because we're B school professors and technologists. What do we know about ethics, right? We outsource that right now across the river to the law school and the philosophy department, right? And so, and the religion department. And so, but as we sort of looked at our work, we said, look, just as I can scale in an exponential way the benefits of AI and networks and value creation, I can also scale the harm. Okay, I can also scale the harm. So the bias in algorithms from data, the fairness questions, and so on. And this is a primary question of concern to business, not just after you built the systems, but beforehand. And so my view is that sort of the work being done in computer science, in philosophy and law around AI ethics actually have to be imported also into the business school world and to business training and business education and for businesses. And we can't anymore sort of defer systems designs just to engineers and say, oops, we didn't realize our data was biased. We didn't realize our labeling was biased or non-representative and so forth. So I think the first stream is that this legislation actually is, the impact is actually more broad-based. So one of our incoming colleagues at HBS is Seth Neal. He did his CS and PhD in CS, and he asked this question in his job talk. He goes, do we want to be fair on average, or do we have to be fair to everybody? Machine learning would say, if I'm fair on average, we're doing good statistically, right? The law says, no, you have to be fair to everybody. So there's a big disconnect. And in fact, I think he had said, don't quote me on this, but it was like a large portion of algorithms today being used by firms today are probably breaking some law because they haven't thought about fairness this way. And in fact, could have these consequences. So all this is pushing into your question about the data, because I think data, the quality of the data, who has permission to it, who has access to it, what is the value of the data? Those are open questions. Does Google really need to save my search from 10 years ago? Probably not, because what they care about is what I'm searching in the moment, right? Because their business model is based on showing me the ad, the relevant ad in the moment, not what I was searching 10 years ago. And the 10 years ago search is probably not that predictive of what I'm searching today anyway, right? And so there's a whole bunch of questions that are being raised for all of us to say, what is the value of data? What's perishability or not? And then what do consumers want? In our Mozilla work, we've been talking about privacy for a long time, but consumers say they care about privacy, but then they act in a very different way. And my colleagues at MIT and also here at HBS have shown that privacy is a weird good. People don't know how to value it. Some of the work that Leslie John has done has shown that, in fact, you can get people to reveal amazingly crazy stuff, amazingly crazy private stuff, simply by the way you show the website to them. And so I think we're at the beginning stages of understanding privacy, consumer preferences. I think people, it's kind of like everybody wants to eat healthy and exercise. And they say, when you ask them, do you care about exercise and eating healthy? Yes. Do you actually do it? No, I'm happy having my cheeseburger again, right? And so I think that's the dilemma we're faced with. And I think there's utility in the data, there's utility in the learning, there's utility in aggregate learning. At the same time, there are these concerns, and we have to figure this out. What's also interesting is that there's a ton of research being done about how I do edge device learning, edge-based learning instead of going to the central cloud. And so anyway, I think this is an important business concern. Policy people need to understand this. I think much of the legislation lags behind practice or doesn't understand consumer behavior. But I think it's a board level issue for companies because they actually have to understand what's at the guts of their systems and are they actually following the rule of the law in the first place, above and beyond everything else that we care about. So I think it's a rich area for people to go create companies in, rich area for people to help companies with and understand.
Nisha, thank you very much for your question.
Sure.
Todd, we have a bunch of questions in Q&A, but I'm wondering if you can let anybody in or if I should ask their question. Specifically, one of Karim's colleagues here from Harvard, Tommaso Davey, asked a question from the Urban Stack Initiative. I wonder if you could just let Tommaso in, or if I should go ahead and ask his question. Let me answer. Well, Karim, I think you can actually see it up there.
Yeah,
right?
I can see it. So can everybody else see the question too?
I don't think so. So maybe if you want to paraphrase it and then answer it.
Yeah, so Tommaso is saying he's a co-founder of the Urban Stack Initiative at the School of Design, which is just across the river from us, and they've built this urban stack. And what they're trying to figure out is, how do we account for the intelligence, interactivity, and connection into our urban stack, right? And do I think if AI will have a big impact on the built environment? I think it's a really good question. So one of my favorite examples, again, these joint MIT Harvard examples. Again, I'm just in this ecosystem a lot. So, I have fewer Stanford examples and more MIT Harvard examples. Is the Street Score project that got developed a few years ago out of the Media Lab. And what they were able to do is use crowd labeling to look at Google Street images to tell you if the street image looked safe or rated out of 10 or something about how safe the street felt to you. And then they had this label data that they built algorithms across sort of the Google Street infrastructure to then predict gentrification, predict values of real estate, predict a whole range of things. So I think becoming smart about the built environment and also sensorifying, and what Ming Zhang from Alibaba says, datafying our infrastructure is actually like a really huge opportunity. And you can imagine, again, we get a bit of this already, like, we have a card access system into our building. So that's doing some location level tracking of me and so forth. How do we use that for good? How do I alert you that you're too close to somebody now in the pandemic? How do I restrict access based on that? How do I, based on the oxygen I'm breathing in and out, in my rooms, come up with some predictions about health and so forth? Alan out of the School of Public Health has done a bunch of work on healthy buildings. Healthy buildings will rely on sensorification, on AI. And just as Google can run 100 million auctions a second, right? The buildings should be able to run a whole bunch of calculations, figuring out where to direct airflow, where to vent air, and so forth, right? And I think that's I think what you're trying to do, I think, in Urban Stack. I think it's a pretty cool thing.
That's really, really fantastic. We have so many questions, but unfortunately we're out of time. You are such an amazing speaker, such a gifted speaker, Karim.
Thanks, Mark.
Really an honor for you to be here today. And I know you were out on your book tour when COVID hit.
Yes.
You had to hightail it out of Europe and get back to the US. But COVID has made your book even more timely.
Yeah. Look, can I show one more graph?
Please.
Let me show one more graph to contextualize all this crazy stuff. So the thing we say in our book is that there's a collision happening. There's a collision happening between what we call sort of digital businesses that have this convex curve of value creation, this exponential curve, set up in a very different way, with a traditional product business that's sort of set up in silos, right? And we've seen this collision over and over again in a range of settings. And so what happens is that the digital business takes a while to get going and to accelerate. And so the traditional business looks down upon the digital business and says, why would I invest? Why would I invest? Why would I invest? And so the collision happens, it's too late, right? So this concave curve intersecting with this convex curve and this collision happening. This is, by the way, the COVID attack on our healthcare system. COVID is an exponential disease, right? Hitting with the flat capacity healthcare system. When we say flatten the curve, what we mean is, right, make sure that this collision doesn't happen, right? And what happens with COVID? Like, it's 2 today, 4 tomorrow, 6 days after. It's an exponential process. It's slow at the beginning, so we get fooled. And the infection rate, the death rate lags, the hospitalization lags, infection, which then further lags the death rate. So it takes us a while for this to get going. But if it gets into a runaway process like it is today in the US, it's too late. It's too late. The collisions happen and we're all in trouble. That's the COVID versus the healthcare. But it's the same mechanism that incumbents face with these digital businesses, right? They don't understand exponential systems. They don't understand how these things take off. And then the collision happens and then they wonder what happened, right? It's the same story. It's the same story. So I didn't know about this. This was done, 3 years ago, 4 years ago, and then we sort of packaged it in our book. But as we were as Marco and I were going around the world and going, holy shit, what's going on? And then we're like, oh yeah, this is exactly the COVID crisis in our collision graph. So anyway, there's a lot.
Quite an amazing analogy. I guess that tells that we need a new architecture for our government too. But that'll be for a whole nother hour and a whole nother story.
Absolutely.
But But the most important thing I do want to say right now is get your surveys in. A lot of people on this call today. We'd like to give out a lot of books. And Karim, we can't thank you enough for being here today. You are truly amazing. Have a really great holiday. I look forward
Thanks,
to
Mark.
seeing you.
Yeah, thanks everybody else for coming. Really appreciate it. Take good care, everybody.
Take care. Bye.